Hello students, welcome to Lucky Learning. Here in this video, I am going to explain you what is transaction properties, we call acid properties, and the states of transaction. Very first, we should understand what is transaction. Transaction is a collection of operations that can perform a single logical unit of work. Here's an example, a transaction which is transferring $50 from account A to account B. How transfer is going to take place? First, it has to be debited from account A, then it has to credited into account B. Debit and credit. How debit can happen? Debit can happen by reading the current value of account A balance from the disk. Let us say data is there in the disk. In the disk, we have the value of A is 500, let us assume, and value of B is 300. Now, to execute this transaction, first it has to read the data that is from the disk, but it has to transfer the data from disk to main memory. And from main memory, it should come to CPU, right? Actually, transactions are going to be executed inside a CPU. Fine. It read the data by reading the data from disk to main memory and then main memory to CPU. So what value it reads? 500. Then it has to perform one CPU operation, A equal to A minus 50, so that it is going to make the value of A to be 450, then write the value of A to the main memory so that it becomes 450. From main memory, it will go to the disk so that it is going to become 450. Once debit is completed, then it has to credit the amount to account B because it is to transfer balance from account A to B. So to credit into account B, it should know what is the current value of account B. Current value of account B is 300. How it can get? It can get from disk to main memory, then from main memory to the CPU. It reads the value of B 300, then add that 50 to the current value so that the B becomes 350. Then this 350 will be returned to the main memory again, and from main memory it will go to the disk. When all these 6 operations are executed, what happened? The amount is debited from account A and credited into account B. But actually, the transfer of data from account A to account B appearing to the user as one operation. But the same to the system, it is appeared as collection of operations. It means these collection of operations that is performing a single logical unit of work, we call one transaction. Means transaction is not just one operation like what user can see. In the point of system, it is a collection of many operations. Whenever a transaction is executing in a system, every transaction that executing in a system must satisfy 4 properties. Those 4 properties are called acid properties. Here, A for atomicity, C for consistency, I for isolation, and D for durability. Because these 4 properties to be satisfied, and from the first letter of these 4 properties are called acid properties: atomicity, consistency, isolation, and durability. Here we will understand what is atomicity, consistency, isolation, and durability. First we'll understand atomicity property. What atomicity property says, if any transaction to be executed, it should execute either all operations of the transaction or none of them to be executed. So means it should execute every operation of the transaction or no operation of the transaction. Why every operation or why no operation? Why not some operation? Let us say an example. This is a transaction which is transferring amount from account A to B. Let us say 50 we are transferring. Now assuming the value of A is 500, the value of B is 300. Suppose if all operations are executed, means amount is debited from account A and credited into account B, makes the value of A and B be 450 and 350 respectively. Then we can call the transaction is success. Amount is debited from account A, credited into account B. Transaction is success and system is in the correct state. Suppose if no operation is executed, means if a transaction is failed before it starts itself. No amount debited from account A, no amount credited into account B, still I can say system is in the correct state, but transaction is failed, then re-execute it, try for one more time. But system is in the correct state. Means system is in the correct state if it executes all the operations or none of them. But suppose if it is executed only some of the operations and a transaction failed. Let us an example, a transaction is failed after debiting from account A before crediting into account B. What happens? Suppose first it is debited from account A. If it is debited from account A, read A 500 minus 50 450 and writes 450 to the database and a transaction is failed. Because transaction is failed, because the transaction is failed, what happens? Amount is debited from account A before crediting to B, it is failed. It leads to incorrect state of the system because from A already debited, but it is not credited to B. Now, is the state is correct? No, it is incorrect state of the system. This incorrect state of the system is possible if transaction not executed all operations or none of the operations. Means if executed all or none, system is in the correct state. If not, then system is in the incorrect state. Here some example is mentioned. If the transaction fails after step 3 and before step 6, money will be lost leading to an inconsistent database state. We also call incorrect state. So means failure occurs after 3 and before step 6. It means all operations are not executed. So that amount is debited from account A before getting into B, it is failed, leading the database system go into inconsistent state. We call incorrect state. That is a first property. Now, the second property is called consistency. Consistency, it is always says that database system should be in the correct state always. So means execution of a transaction in isolation preserves consistency of the database. It means correctness of the database. System always should be in the correct state. Correctness of the database. It should never be in the incorrect state. How it can knows the system is in the correct state or not? That correctness checks to be written by the application programmer. It means consistency is ensured by application programmer who writes an application program over the database. So application programmer means who develop user interface that uses the database to execute the query. Means database is the backend, front end is the user interface. The person who writes front end programs, application programs, are called application programmer. Now this application programmer should write some test cases such that he can check is the system leaded to consistent state or inconsistent state. So some example of consistency check. The sum of A and B is unchanged by execution of the transaction. Suppose before execution of the transaction, what is the total balances of A plus B? Now 500 plus 300, that is 800. After execution also it should be 800. That is 450 plus 350 if transaction executed successfully. You will get 800. So before transaction and after transaction, some of the balances are same, then we can call system leaded to consistent state. But suppose before transaction starts, some of the balance is for 500 plus 300, that is 800. After transaction completes, or else after the transaction, suppose here a failure occurs at the third step. What is the value of A? 450. What is the value of B? 350, not 300. Then what is the result? 750. But what was the balance? Sum of the balances before it starts? 800. Now after the transaction failed, what is the sum of the balances? 750, means both are incorrect. Then it is announced that some error occurred in the database system. So such kind of consistency checks to be written by the application programmer who develop an application program over the database system. Similarly, for ensuring atomicity in a database system, we have a component called transaction manager. It is a database system component which is used to test atomicity property. Then coming to the third property, we call isolation. What isolation says, when multiple transactions may execute concurrently. Concurrently means simultaneously multiple transactions are executing. And each transaction must be unaware of other concurrently executing transactions. Means each transaction don't know what is happening with other transactions. And intermediate transaction results, whatever the results happened, intermediate uh, results happened on the transaction, these are hidden from other concurrently executing transactions. It means when two transactions are executing, let us say Ti and Tj are executing, it appears to Ti that Tj finished execution before Ti started, or Tj started execution after Ti finished. Means it appears to Ti that J might be executed before I started, or J is going to be executed after I completed. Means the effect of execution to Ti, it appears that either J may be finished or J may be continue its execution after I completed. Then I can call the Ti never knows what happened with Tj. It is an isolation property. Means I does not know what happened with J. J does not know what happened with I. It's called isolation property. Here, I gave you a simple example. This is a transaction which is transferring balance from account A to account B. How much balance? 50 is transferred. Now, first it has to perform a debit. This is a debit transaction. And then it has to perform a credit. First debit from account A, then credit into account B. Suppose between these two operations, debit and credit, suppose if other transaction T2 reading the value of A, reading the value of B and printing some of the balances. Let us say A is 500 and B is 300. Then what happens? It reads 500 minus 50, 450 and writes 450. So the value of A is 450. Then before it credits into account B, this reads the value of A 450 and reads the value of B 300 and prints the sum of the balances 750. But this 750 is the incorrect result. This is incorrect results. Why this happened? Because because T2 don't know what happened with T1. Now see if between steps 3 and 6, another transaction T2 is allowed to access the partially updated database. Now it is updated 450, but that update happens first to the main memory, later to the disk. But it is updated to the main memory, but it is not updated to the disk because disk is having 500 and 300 only. This update is called partial update, and this partial update is read by the transaction 2, right? So what transaction 2 is allowed to access the partially updated database? It will see an inconsistent database state, that is sum of A plus B will be less than what it should be. Now what is the sum of A plus B? Sum of A plus B expecting to be 500 plus 300, that is 800, but transaction 1 was not completed, but it read inconsistent value or partially committed values. that is from the main memory. It means why it is called partially committed, because it is reading from the main memory before it is affecting to the disk. We call it as a partial update. So that what sum of the balances it is displayed 750, it is incorrect. So inconsistency is possible. This problem to be resolved means isolation problem, means transactions if executed isolatedly, problems may be possible. To control these problems in a database system, we have a component called concurrency control manager. We have a component called concurrency control manager, which is responsible for concurrent execution of the transactions, and it control their execution so that database system should go into correct state. It should never be in the incorrect state. Then we'll go ahead with the fourth property called durability. What durability says, after a transaction completes successfully, the changes it has made to the database persist. What does it mean persist? We call permanent. This is going to become permanent. Why? Because the values are there in the disk A500 and B300, so that these values should come to main memory. So A500, B300. So what it happens, first it reads from the main memory 500 minus 50 450, writes 450 to the main memory. Maybe it is affecting to the disk after some time. Then read B 300 plus 50 350, writes 350 and to the main memory, and these updates may be affecting to the disk afterwards. But before it is affecting to the disk, if any crash occurred, contents in the main memory is going to be lost. But transaction is completed partially because it is executed all the operations and updates are affected to the main memory. But before these updates are affecting to the disk, if a system crash occurs, but these updates should become permanent updates, because these updates are temporary updates. Before these temporary updates become permanent, crash occurred. But what system should do? System should detect what updates done to the main memory, and that updates should be affecting to the disk so that it is making that updates to become permanent. That is what we call persistent. Means if transaction completes successfully, it is a meaning that all updates are written to the main memory. The changes it has made to the database, it is a meaning that the changes it has made to the main memory should become permanent even if there are system failures. Even if a system failed occurs, these updates should be still, it can be stored into the disk. For doing this in a database system, we have a component called recovery manager. This recovery manager is going to maintain activity of transaction, like transaction hold values what, let us say 500, new value what, 450, that old value, new value, what data item it is updated. These things should be stored into the, should be maintained by the recovery manager. And because that information is available, even a system crash occurs, that update should be affected to the disk even after the system crash occurs. Let us an example. Once the user has been noticed that the transaction has completed, and that is the transfer of $50 has taken place, means completed, means debited from account A credited to account B, the updates to the database by the transaction must persist. It means must become permanent even if there are software failures or hardware failures. This property is called durability. So what we conclude is every transaction must satisfy four properties. What are the four properties? Atomicity, consistency, C, consistency, I, isolation, and D, durability. So every transaction must satisfy these four properties. From the first letter of each property, these properties are called acid properties. Atomicity, consistency, isolation, and durability. These are called acid properties. Next, we'll understand what is transaction states. we have discussed one example, that is transferring balance from account A to B 50. How this is done? First debited from account A by reading the value of A from the disk to main memory to CPU, then write that update, then read the value of B, then B should be updated, and this is one transaction we have discussed. Now here we should understand what are the states of a transaction. Whenever a transaction is executed, we call it is active state. And is this execution continues till to the end? Okay, suppose if this execution completed all the operations, then we call partially committed. And when this execution completed all the operations, these writes are affected to the main memory. And these main memory effects, whenever it goes to the disk, means update should become permanent. Then we can call committed states. Means before updates committed, means before updates transferred to the disk, a failure may be possible. Means a failure may occur in the middle of the transaction when it is executed. Means from active it can go to the failed state. Or a crash may occur even after all the operations of a transactions are completed. Means if all operations are completed, it is partially committed. From partially committed, still it can go to the failed state. If a transaction goes into failed state, system is in the incorrect state. Once system is in the incorrect state, it can be bring back to the correct state. Bringing back to the correct state is called aborted state. Means once system brought back to the previous correct state, we call aborted state. At this point, transaction can perform either one of the two operations, whether transaction can be restarted or transaction can be killed. Transaction is restarted if the failure is due to software or hardware, and transaction is killed if the failure is due to and transaction is killed if the failure is due to logical error. What does it mean? Example of logical error. Suppose I am trying to withdraw 5,000 rupees from my account, but actually my account is having 2,000 only. So when my account is having 2,000, withdrawal of 5,000 never be possible. It means re-executing of the transaction will never gives you successful uh, transaction, so that it is required to be killed, right? If it is a software failure or hardware failure, suppose if bug in the database system software and transaction is failed, bring this transaction database system to the correct state and then re-execute the transaction. That is called restart. Now for your understanding, here I have written some notes for you. What is active? The initial state, and the transaction state in the state while it is executing. And what is partially committed? After the final statement has been executed. When I can call failed? After the discovery that normal execution can no longer proceed. Aborted means after the transaction has been rolled back, means change it back to the previous correct state. The database restored to its state prior to the state of the transaction. So when if it is aborted, we have two options. One is restart, another is kill the transaction. And restart is required if there is a software failure or if there is a hardware failure, but not internal logical error. If it is an internal logical error, we can go with a kill operation. Means transaction is to be killed. Killed is nothing but it is suspended from the database so that it never re-executed once again. And when we can call transaction is committed, total transaction is successfully completed, means updates are affected to the main memory, from main memory it goes to the disk, then we can call transaction is committed. So this is all about what is transaction, transaction properties, transaction states. Hope you understood, and if you like the video, please do like, share and subscribe. And more importantly, the notes, whatever the PPT I am using, the notes is uploaded in a drive and that link is shared for you, so you can download the notes for reading purpose.